In the name of God, the most merciful, may the peace be upon you and God's mercy and blessings. We will solve practice problem 732, which is about developing load function W of x, shear function V of x, and moment function M of x by using the discontinuity function. The practice problem is included in Professor Timothy Philpot's book, An Integrated Learning System, Mechanics of Materials. The same practice problem is P7-56 in the third edition. We have a given beam with a span of 9 feet acted upon by two concentrated loads. P1 equals 180 pounds and the second concentrated load is P2 equals 450 pounds. The both two loads acting downwards. It is required in part A to use the discontinuity function to write the expression for load W of x in part A and to include beam reaction in the expression. In part B, it is required to integrate W of x twice to determine the Vx and M of x. In part C, it is needed to use Vx and M of x to plot shear force and bending moment diagrams. First, we draw the free body diagram for the beam, which includes two reaction forces for the hinged support A, which are A sub x and A sub y. While for support D, which is a roller support, it has only one reaction, which is D of y. Using the three equations of equilibrium, sigma x equals 0, sigma y equals 0, and sigma m equals 0, following the standard rule for directions. For horizontal loads, the positive direction is to the right. For vertical loads, the positive direction is to the upward direction. For moments, the positive direction is anti-clockwise direction. We do not have any acting horizontal loads, so A sub x equals 0. From sum of y equals 0, ay plus dy equal 180 plus 450 equals 630 pounds. From sum of moment M about D equals 0, take in the moment for all forces about the right support D by multiplying each force and reactions by the arm length to support D and considering the directions of moment rotations, minus ay multiplied by 9 plus 180 multiplied by 7 plus 450 multiplied by 3 equals 0. Ay value equals 290 pounds with a positive sign that includes that the upward direction is the correct sign. From sum of y equals 0, g sub y equals 630 minus 290 equals 340 pounds acting upwards. In the next slide, we are ready to write the expression for W of x for the given beam. This is case 2 from the discontinuity table discussed in the previous video. Take the left point A as your 0, point, the horizontal axis x, while the y-axis will be W of x. It is important to follow the positive direction, which is the upward direction for positive loads. The reaction AY is upward, so it is positive, acting at x equals 0. So we write 290 multiplied by x minus 0 raised to the power of minus 1, since we are dealing with the load intensity. After 2 feet comes a downward load of 180 pounds, so the expression is minus 180 multiplied by x minus 2 raised to the power of minus 1. At x equals 6 feet, there is another downward load of 450 pounds. Its expression is minus 450 multiplied by x minus 6 raised to the power of minus 1. Finally, the dy of 340 pounds acts at x equal 9 feet. The wx equals 290 multiplied by x minus 0 raised to the power of minus 1 minus 180 by x minus 2 raised to the power of minus 1 minus 450 multiplied by x minus 6 raised to the power of minus 1 plus 340 multiplied by x minus 9 raised to the power of minus 1. The last reaction while calculating will be ignored in the calculation since it represents a step function for distance bigger than 9 feet. The next step is to integrate 1 to get the v of x for shear. So v of x equals 290 multiplied by x minus 0 raised to the power of 0 minus 180 multiplied by x minus 2 raised to the power of 0 minus 450 multiplied by x minus 6 raised to the power of 0 plus 340 multiplied by x minus 9 raised to the power of 0. We have integrated by adding only n plus 1 to all minus 1s. Again, integrate to get the value of m of x. M of x equals 290 multiplied by x minus 0 raised to the power of 1 minus 180 multiplied by x minus 2 raised to the power of 1 minus 450 multiplied by x minus 6 raised to the power of 1 plus 340 multiplied by x minus 9 raised to the power of 1. Then parts A and B were completed. In the next slide, we write the expression for v of x. For values bigger than a, the term is positive raised to the power of 0 equals 1, while for values less than a, the negative value will be treated as zeros. If x minus a is negative value, it will be equated to 0. v of x equals 290 multiplied by x minus 0 raised to the power of 0 minus 180 multiplied by x minus 2 raised to the power of 0 minus 450 multiplied by x minus 6 raised to the power of 0 plus 340 multiplied by x minus 9 raised to the power of 0. For x minus 0 raised to the power of 0, we consider what is called 0 plus. 0 plus means a small value more than 0. It will be equal 1 if x minus 2 raised to the power of 0. If the x is less than 2, then it will be considered 0, while for x bigger than 2, it will be considered positive. X minus 6 raised to the power of 0. If x is less than 6, will be considered 0, while if x bigger than 6, the term will be positive. For x minus 9 raised to the power of 0, if x is less than 9, the term will be considered 0, while if x bigger than 9, the term will be considered positive. We will expect to have two steps at x equal to 2 feet and at x equals 6 feet for shear values. We consider x equals 0 plus, so v of x equals 0 plus equals 290 by 1 equal 290 pounds. We consider x equal 1 foot, so V of x equal 1 equals 290 multiplied by 1 minus 180 multiplied of 1 minus 2 raised to the power of 0. This term is negative. It will be considered 0. So we have 290 minus 0 minus 450 multiplied by a negative value considered 0. So the final answer is 290 pounds. We consider x equal to 2 feet. So Vx of 2 equals 290 multiplied by 2 minus 0 raised to the power of 0 minus 180 multiplied by 2 minus 2 raised to the power of 0 minus 450 multiplied by 2 minus 6 raised to the power of 0. The middle term and the last term will be considered 0. So the final value is 290 pounds. We consider x equals to 2 plus or small amount more than 2. So Vx equals to 2 plus equals 290 multiplied by 2 minus 180 multiplied by 2 plus minus 2 raised to the power of 0. It would be considered positive, so we have 290 by 2 290 multiplied by 2 raised to the power of 0 is equal 290 minus 180 equals 110 pounds. We consider x equal to 3 foot, so Vx of 3 equals 290 multiplied by 3 minus 0 raised to the power of 0 minus 180 multiplied by 3 minus 2 raised to the power of 0 minus 450 multiplied by 3 minus 6 raised to the power of 0 equals 290 minus 180 minus 0 equals 110 pounds. We consider x equals 4 feet, so Vx of equals 4 equals 290 multiplied by 4 minus 0 raised to the power of 0 minus 180 multiplied by 4 minus 2 raised to the power of 0 minus 450 multiplied by 4 minus 6 raised to the power of 0. The last term will be considered 0. So we have 290 minus 180 minus 0 equals 110 pounds. We consider x equals 5 feet. So V of x minus 5, x equals 5, equals 290 multiplied by 5 minus 0 raised to the power of 0 minus 180 multiplied by 5 minus 2 raised to the power of 0 minus 450 multiplied by 5 minus 6 raised to the power of 0. The last term is considered 0. So we have 290 minus 180 equals 110 pounds. In the next slide, we continue to find the values for V of x for 6 feet, 7 feet, 8 feet, and 9 feet. We consider x equals 6, so V of x equals 6 equals 290 multiplied by 6 minus 0 raised to the power of 0 minus 180 multiplied by 6 minus 2 raised to the power of 0 minus 450 multiplied by 6 minus 6 raised to the power of 0 equals 290 minus 180. The last term would be considered 0, so we have again 110 pounds. We consider x equal to 6 plus. 6 plus means small amount more than 6. So Vx equal to 6 plus equals 290 multiplied by 6 minus 0 raised to the power of 0 minus 180 multiplied by 6 minus 2 raised to the power of 0 minus 450 multiplied by 6 plus minus 6 raised to the power of 0 equals 290 minus 180 minus 450 equals 340 pounds. We find out that there is a drop or change step. At 6 feet, we have 110, while at 6 plus, same point, but we will have a step by the value. So the shear value will be minus 340 pounds. We consider x equal to 7 feet, so V of x equals 7 equals 290 multiplied by 7 minus 0 raised to the power of 0, minus 180 multiplied by 7 minus 2 raised to the power of 0, minus 450 multiplied by 7 minus 6 raised to the power of 0, equals 290 minus 180 minus 450 equals minus 340 pounds. We consider x equals 8 feet, so V of x equals 8 equals 290 by 8 minus 0 raised to the power of 0, minus 180 multiplied by 8 minus 2 raised to the power of 0, minus 450 multiplied by 8 minus 6 raised to the power of 0 equals 290 minus 180 minus 450 equals minus 340 pounds. We consider x equals 9 feet, so Vx equals 9 equals 290 by 9 minus 0 raised to the power of 0 minus 180 multiplied by 9 minus 2 raised to the power of 0 plus 340 multiplied by 9 minus 9 raised to the power of 0 equals 290 minus 180 minus 450 plus 0 equals 300 minus 340 pounds, which is numerically equal to gy value, but negative since it represents the shear value. In the next slide, we write the expression for m of x. M of x equals 290 multiplied by x minus 0 raised to the power of 1, minus 180 multiplied by x minus 2 raised to the power of 1, minus 450 multiplied by x minus 6 raised to the power of 1, plus 340 multiplied by x minus 9 raised to the power of 1. For values bigger than a, the term is a positive raised to the power of 1, while for values less than a, the negative value will be treated as 0. I mean x minus a. We consider x equals 0, so m of x equals 0 equals 290 multiplied by 0 minus 0 raised to the power of 1 equals 0 pound feet. We consider x equal 1, so m of x equals 1 equals 290 multiplied by 1 raised to the power of 1 equals 290 pound foot. We consider x equal to foot, so m of x equal 2 equals 290 multiplied by 2 minus 0 minus 182 minus 2 raised to the power of 1 minus 0. We have 290 by 2 minus 0 equals 580 pound feet. We consider x equal to 3 feet, so m of x equals 3 equals 290 multiplied by 3 raised to the power of 1 minus 180 multiplied by 3 minus 2 raised to the power of 1 minus 0 equals 290 by 3 minus 180 equals 690 pound foot. We consider x equal to 4, so m of x equal 4 equals 290 by 4 minus 180 multiplied by 4 minus 2 raised to the power of 1 minus 0 equals 290 multiplied by 4 minus 180 multiplied by 2 equals 800 pound foot. We consider x equal to 6 feet, so m of x equal to 6 equals 290 by 6 raised to the power of 1 minus 180 multiplied by 6 minus 2 raised to the power of 1 minus 0 equals 290 by 6 minus 180 by 3 equals 1020 pound-foot. In the next slide, we continue to find the values for m of x for 7, 8, and 9 feet. We consider x equals 7, so m of x equals 7 equals 290 by 7 raised to the power of 1 minus 180 multiplied by 7 minus 2 raised to the power of 1 minus 450 multiplied by 7 minus 6 raised to the power of 1 equals 2030 minus 900 minus 450 equals 680 pound-feet. For x equal 8 feet, m of x equal 8 equals 290 by 8 raised to the power of 1 minus 180 multiplied by 8 minus 2 raised to the power of 1 minus 450 multiplied by 8 minus 6 raised to the power of 1 equals 2320 minus 1080 minus 900 equal to 340 pound-feet. For x equal 9 feet, m of x 9 equals 290 by 9 minus 180 multiplied by 9 minus 2 raised to the power of 1 minus 450 multiplied by 9 minus 6 raised to the power of 1 minus 0 equals 0 pound-foot. In the next slide, based on the information and estimations, two sketches for both v of x and m of x are drawn. We have a drop in shear value at x equal to 2 and also at x equal to 6. We have positive and negative values in the shear force diagram. The positive values are drawn above the datum line, while the negative values are drawn below the datum line. All the values of m of x are positive. It is drawn above the datum line. In the next slide, I used an Excel sheet. First, I checked the values of AY and DY by using both the sum for vertical loads and the sum of moments at both A and D by using rows from 1 to 8. I have initiated a table for X values and placed the X equal to 2 feet twice and X for 6 feet twice. To create a step in the Excel sheet, remember that we have P of X equal 290 multiplied by X minus 0 raised to the power of 0 minus 180 multiplied by X minus 2 raised to the power of 0 minus 450 multiplied by X minus 6 raised to the power of 0 plus 340 by X minus 9 raised to the power of 0. In Excel sheet, I used the if then else function. It contains 3 conditions. The first condition is from 0 to 2, followed by x bigger than or equal to 2 to x equal to smaller than equal 6, and the third condition is x bigger than 6 to x equal to 9. The value of shear is used in cell B15 for the condition. The if condition for cell B15 equals if and we open one bracket, we have A14 equals 0, comma A14 less than 2, comma 290. 290 is the AY value which we have started with. The second condition, if and open one bracket, we have A14 equals 2, bigger than 2, comma A14 less than 6, comma, we have two values, 290 minus 180. The third condition, if and A14 equals or bigger than 6, comma A14 less than or equal 9. We close the parentheses, and we make comma 290 minus 180 minus 450. These are the equations for shear, and for the values x minus 2 raised to the power of 0, in Excel we use 1. So we kept to 290 as if we are writing 290 by 1 minus 180 by 1 minus 450 by 1, comma 0. And how many brackets we have? We have 3 because we have 3 conditions. A14 here represents the x value. In the first term, we included 290. In the second term, we included 290 minus 180. And in the third term, we included 290 minus 180 minus 450. To create step at x equal to 2, we consider the term as smaller than and equal to 2. We use A16 said in the statement as follows. If and A16 equals 0, comma, A16 smaller than or equal to, we close the brackets and we use comma 290. If and A16 bigger than 2 and less than 6, comma 290 minus 180, if and A16 equals 6, comma A16 equals and smaller than 9, we close the bracket and we have 290 minus 180 minus 450, comma 0, and we have 3 brackets. While in the second term we use bigger than or equal to, we use A17 cell in the statement as follows. If and A17 equals 0, comma A17 less than 2, we close, comma 290. And then the second statement, if and A17 equals 2 and bigger or bigger than 2, comma A17 less than 6, we close the bracket, comma 290 minus 180. The third statement, comma, if and A17 bigger than or equal 6, comma A17 equals and smaller than 9, we close and we write 290 minus 180 minus 450, comma 0, and then we have the 3 brackets for the 3 conditions. In the next slide, we see the equation for a step for the first x equal to 6 value. To create step at x equal to 6, we consider the term as smaller than or equal to 6. We use cell A21. If and, we open one bracket, A21 equals or bigger than 0, comma A21 less than 2, comma 290. Second statement, if and A21 equals to bigger than 2, comma A21 less than or equal 6. Because this is the first 6, we are concerned by the equal and less than to catch in the process to catch the first 6. Comma 290 minus 180. The third condition, if and A21 bigger than 6, less, comma A14 A21 less than 9, comma 290 minus 180 minus 450, comma 0, and 3 brackets. In the second term, for 6 bigger than or equal 6 in cell A22, to represent the shear value at the other 6 where the step occurs, if and A22 equals or bigger than 0, comma A22 less than or 2, we close, comma 290, and if and A22 equals or bigger than 2, comma A22 less than 6, we don't put equal here, comma 290 minus 180 if and A22 equals and bigger than 6. This is here in order to find the step value, comma A22 less than or equal to 9. We close and then we write 290 minus 180 minus 450, comma 0, and we have 3 brackets. In the next slide, please find the plot of shear force created by using graph of an Excel sheet. The plot matches with the previous plot which we have done based on the calculation before. In the last slide, the moment function is m of x equals 290 multiplied by x minus 0 raised to the power of 1, minus 180 multiplied by x minus 2 raised to the power of 1, minus 450 by x minus 6 raised to the power of 1, plus 340 multiplied by x minus 9 raised to the power of 1. I have used the function as for cell C14, if and then open one bracket, A14 equals or bigger than 0, comma A14 less than or equal to, we close the bracket, and then comma 290 by A14, because we are checking for the moment. The moment value is force by distance. Comma if and A14 equals to 2, comma A14 less than or equal 6. We close and then we write 290 by A14. This is the second condition. We will add 180 multiplied by A14 minus 2. Our expression is x minus 2, but here A14, the cell A14 represents the x. We close the bracket and then we write comma, if and then A14 equals to 6, comma A14 less than or equal 9, comma 290 again by A14 minus 180 multiplied by A14 minus 2. Then we add minus 450 by A14 minus 6. A14 here again represents the x value, comma 0, and then we have 3 brackets. The sketch of moment is drawn by using the Excel graph. Thank you, and peace be upon you all. Goodbye.